So, as I said, today we are going to talk about regression. We are going to start with our actual machine learning models, and regression analysis or regression models are one of the important models in machine learning. Now, guys, at first we need to understand that why. What is basically regression? Okay, if you remember in the very first lecture of machine learning, I have described like there are two different subtopics in machine learning. We have something called as supervised learning, we have something called as unsupervised learning, right? So regression is a, part which comes under supervised learning, guys. Okay, that means in regression we have a x variable and we have a y variable. Okay, and when this y variable is continuous in nature, we perform regression. When the y variable is discrete or categorical in nature, we perform classification, right? So in other words, you can also say regression is a supervised machine learning, let's say, technique where data is continuous in nature. Okay, regression is a supervised learning technique where data is in continuous in nature. Basically, specifically your target variable is continuous in nature. If you remember, this was the example that I had taken on that day while describing the definition of classification, and over here regression. You can see that in classification the y variable, basically the output, is categorical in nature, right? Whereas this input over here can be continuous in nature, right? Apart from this, if we talk about the need of regression, that why do exactly we need a regression at the first place? Okay, so, guys, if you remember during your DWD topics, I have informed you about certain terms, about certain bivariate terms. Like we all know that when it comes to measure of central tendencies, when it comes to dispersion, right, we can perform it on a single variable. Basically, in measure of central tendency, we are trying to understand our data, we are trying to describe our data using measure of central tendency and dispersion techniques, right? But when it comes to regression, all right, this is a bivariate thing, and there are not only regression but there are certain things that we should understand first before moving ahead to know what exactly regression or linear regression is, to be exact. Okay, so as informed earlier as well, there are four different things. First, when it comes to bivariate analysis, when it comes to analyzing two different variables, okay, when it comes to checking whether there is a relationship or association between two variables, there are four terms that we use. First, there is something called as covariance. Okay, now covariance is a term, right, which helps us to understand that whether or is there any relationship or is there any association between your two variables. Okay, is there any relationship or is there any association between your two variables, either x or y. Okay, for example, let us say I have this graph, okay, wherein I have two different lines, okay, something like this, and then I also have a line like this, right? Now we need to check, is these two lines are related, is these two lines are associated, whether the change will occur on line 1 that will reflect on line 2 as well, is there any some relationship, is there any association between these two lines or not. Okay, when it comes to this yes or no, let's say question, we use covariance because this is the term, or this is the, let's say, tool which will help us to understand whether there is a association or whether there is a, let's say, relationship between two variable or not. Okay, but the problem over here is the value of covariance lies between minus infinity to plus infinity. Okay, that means the value can be any big and any small. All right, we cannot, I mean, we don't have any definite range. Sir, why do we need range? Because guys, let's say, definitely covariance is telling us whether there is a relationship or not. Okay, whether there is any association or not. But what if I want to understand that if there is any relationship, then how strong the relationship is, or I want to understand how weak the relationship is. Okay, so when it comes to this how question, covariance will not be able to answer that. Okay, it can only tell me yes, that there is a relationship, or no, that there no there, I mean, there is not any relationship, or there is no association between two variables. That is your, let's say, x over here. Okay, that is your, let's say, x and y. Okay, so for understanding that how good or how bad the relationship or association is between two variables, we have something called as correlation. Okay, we have something called as correlation. Now guys, when it comes to correlation, the value of correlation lies between -1 to +1. Okay, now here we can definitely say that how good or how bad the relationship or association is between two variables. Okay, we can say that if the value of correlation is close to negative or positive 1, they have very strong relationship. And if the value of correlation is near or close to 0, they have bad relationship or weak relationship, sometimes no relationship or no association between x and y. Okay, so if you want to understand the answer how, go for I mean, correlation. And now let me introduce you with the third term, that is the today's topic actually, regression. Now we do regression, we perform regression, specifically we perform linear regression to understand that what would be the effect. Okay, what would be the effect on y variable given the input x. Okay, given the input x by using this formula, that is y is equals to mx plus c. Okay, so these are the, I mean, this is the formula that we are going to use in your regression problem, specifically linear regression problem. Now I'll tell you why in linear relationship or linear regression problem. But before that, let us, I mean, dive a little bit more deeper into regression. So as I said, if you want to understand that what would be the value of y given an input x, then regression would be the best technique that you must use. Now if you go through with the entire covariance, correlation and regression, again I repeat, when it comes to yes or no answer, that whether there is a relationship or not, we consider covariance. But covariance cannot tell me how good or bad the relationship is, or how good or bad the association is, right? So for that, for, I mean, knowing the answer of how, we perform correlation, right? But correlation cannot tell me that if we change a particular number on x, what will be the effect on y. Okay, if you want to know about the effect, okay, if you want to know about the, let's say, relationship, the actual relationship between x and y, if you want to establish the relationship between x and y, we must perform regression. And again, regression is a supervised learning technique where we have target variable in continuous in nature, or you can say numeric in nature. All right, So this is why we use regression analysis to know what would be the effect on y given the value of x. Okay, is that clear till here everyone?